Okay, so on your own paper, I want you guys to draw something that looks kind of like this. This is called a Frayer map. It's one way to like organize your thoughts and ideas about different concepts. We're going to make this Frayer map about functions. You guys had the opportunity yesterday to look up definitions and examples for functions. And so we're going to make this Frayer map here to kind of help guide us as we move forward. I want to get a definition written for us. I'm going to go ahead, I'm going to define a function as a relationship between two variables where one element or piece of the domain or the input maps to exactly one element of the range. Range is our output. Make that fit in that space just a little bit better. So there's our working definition. For a function. Good afternoon, Nasiba. There are a couple really important characteristics for functions. One of the biggest, most important characteristics is that no x's repeat. If you see an X on a table that repeats itself or an X in a list of ordered pairs that repeats itself, it has to go to the same Y value. Basically, they just double printed it. It's redundant. So if you see an X repeat itself, it has to go to the same Y value. The Y's are allowed to repeat. X's can't, but the Y's can. You can have a lot of the same Y's. In fact, you can have a bunch of different X's that all share the exact same Y, and that's okay. That is absolutely fine. when we're looking at a graph, there's another characteristic that we can look out for. On a graph, we would say that it passes the vertical line test. I'm going to have two different examples here of our vertical line test, something that passes and something that fails. If I have a graph like, I don't know, like this parabola right here, if I draw a series of vertical lines on it, and no matter where I draw those vertical lines, it only crosses my blue parabola in one spot each time, it passes. If I have another shape though, like say I have a graph over here with a circle on it, if I were to draw a vertical line here on this graph, do you guys see how it crosses my circle twice? If it crosses my graph in more than one spot, then it fails. That would be an example of an X that has two different Ys. That'd be my output. That is not a function. All right. I would like to try to get at least 4 good examples of things that are functions, and at least 4 good examples of things that are not functions. I want you guys to type some ideas into the chat. It can be descriptions of shapes. It can be equations. You could type in tables. I want you to give me some examples of things, and we are going to categorize them as either functions or not functions. I'm going to give you guys a couple minutes to think about that. And type your ideas into the chat. Please feel free to send them to me as direct messages so that I'm the only one that can see it. And then we can talk about them. And you don't have to state ahead of time whether you think it's an example or a non-example. Just give me some different things and we'll put them up and we'll discuss. All right. I've got an entry here. All right, so the first one that I've got is the ordered pair 4, 4. You guys think that that would be a function or not a function? Do we have X's that repeat themselves here? Function or not a function? It is a function. Yeah. So I'd put that over here in my examples list. No worries, no worries. I'm glad you were able to make it. What about if we added some more ordered pairs to that? If I had 4, 4, and then we also had 2, 2, and 3, 1, and 5, 7. Oh, I like it. Thank you, Rana. Would this list of ordered pairs be a function or not a function? What do you guys think? Function or not a function? If I have a whole list of ordered pairs like this. That is a function, yes. When I look through it, I notice that none of these x's ever repeat. And so this would be a function. So I'm going to add that to our function example list. What about if I had almost the exact same list, but say right here, that one little change happened? Would that be a function or not a function? That is not a function. Why not? Why is that not a function? X repeats itself right here. And it goes to two different Y's. So I would take this and I would put that on my non-example list. I'm going to try one more with this, and then I'm going to get the table that you suggested, Rihanna, and we'll get that up. What about that? Function or not? Function or not? This is a function. Nice job, Nasiba. Why is it a function? My x's repeat. Normally that's cause to throw it out. Certainly is enough to make me raise my eyebrows, but then it's going the same y. It's just redundant. It's like typing the same word twice in a text. This is a function. So I'm going to add that to our function list. Beautiful. Okay, I'm going to get that table up. So there was an XY table that was given. And we're going to decide whether it is a function or not a function. So down the X side, we have 1, 2, 3, 4, 5, 6. And down the Y side, we have 2, 4, 6, 8, 10, and 12. Function or not a function? Function or not a function? Function, yes. Why? Why is it a function? X's don't repeat. Beautiful. What about this? Function or not a function? Not a function. Why? 1 repeats itself right here and right here. And it's not going to the same Y each time. Same X, different Y means not a function. Ooh, thank you. We have our first equation. Y equals 9x plus 6. Function or not a function? Function or not a function? This one is a function. What about, see if we can get some shapes. I'm going to steal from up above. Would this be a function or not a function? Yes, that one would be a function. If I had a parabola like that, an equation that would go with it, I don't know if you guys remember this from Algebra 2 at all, but this would be like y equals x squared minus 1. That is the equation for a parabola. So if a parabola is a function, then the equation that describes it would also be a function. What about a circle? Function or not a function? Not a function. Because it's going to fail our vertical line test there. What about if I took a parabola like y equals x squared minus 1? What about if I took that parabola and I turned it on its side? Function or not a function? Not a function. Fails again. So a parabola is, and that has an x squared in it. Let's talk about some equations that would describe these different shapes here. To describe a circle, we would have an x squared plus y squared equation. So x squared plus y squared equals, I don't know, 4, something like that. This is the equation for a circle. Anytime you see a y squared, that means 2 y values for the same x. That's exactly what we see happening in that sideways parabola. That sideways parabola could have an equation that was, say, y squared equals x. This tells me one x has 2 different y's. So that would throw it out. Not going to work. There was one other kind of representation that you guys had yesterday when you were doing the card sort between function and not a function. And it was the ones that looked kind of like this. And then they had some arrows between them. So if I had something like 1, 2, 3, and a 7 over here, do you think something like this would qualify as a function or not a function? Function or not a function? Nice job, Rana. That is a function. You can have lots of x's going to the same y, and that is absolutely allowed. What about if I switched it around the other way? Same numbers, backwards order. Is that a function? No. Why not? Yes. 7, our input, has lots of different outputs. It's not assigned to only one output. Our x's can only be assigned to one output in order to qualify as functions. Awesome. Awesome, awesome, awesome. Okay, what we're going to do for the rest of our time today, we are going to hop back into the Desmos that we were working on yesterday, except now I want you guys to advance to screen number 4. So on our class Canvas page, underneath Frayer Map, if you go to the today's lesson page, Underneath the Frayer map, you'll see a link for 7th period. You want to click on that link and you want to get back into that. Just like we did yesterday, you're going to click on the link, continue without signing in, type in your name, and then I want you to advance to screen number 4. And I'll give you guys directions from there. I'm going to leave this up on the screen for just another minute in case people are still writing this down. Awesome, Lauren, I see you there. On screen 4, as you guys are getting in there, Yasmin, I see you. You guys are going to be dividing these cards. These are all functions. So we're not doing the function, not a function on screen 4. We're going to divide them into linear or not linear. Is it a linear function or is it a non-linear function? Nicole, I see you in there. Rihanna, I see you as well. Kyla, Brennan, and Nasiba. I don't see you guys yet. Oh, Nasiba, there you are. So Kyla and Brennan, I don't see you guys over in the Desmos yet, but I want you to advance to screen number 4. So up at the top, you're gonna use the next button to get over to screen 4. There's a card sort there. Everything on that screen is a function. I just want you to separate them now into things that are linear and non-linear. Right, let me pull that up on my end. Come on. It's not letting me get out of full screen over here. There we go. I don't know why it wasn't working there. There we go. So over here, you want to be on screen 4. Remember, if you make it full screen, it'll make it easier to see those cards. There should be a little card that says linear and then another little card that says non-linear. And you're going to group them together. And then just like yesterday, you can go forward and you have a check page right here. You have to press that try button, but then it'll tell you how many cards you have sorted correctly. So you want to get them into linear and not linear. And my hint for you is in order to be linear, that means that it has a constant rate of change. We refer to a constant rate of change as the slope. If you see it changing by a constant amount, then it would be a linear function. See, Kyla, I still don't see you, but I see everybody else. Nicole, you want to press this next button up here in the corner, right here, to go over to screen number 4. You want to be looking at the card sort that's on screen 4. The check page for screen 4 is on screen 5. So you want to go between 4 and 5. Brennan, you want to go forward to screen number 4. And you want to try to match those there. Kyla, there you are. At least I think. Oh, yep. There you are. There you are. You want to go forward to screen 4. Perfect. Making your way over there. Looking good. So go back and forth between screens 4 and 5 as you match these. Brennan, looking good. Nasiba, awesome. You want to go until you get all of them matched into their correct categories. It'll give you stars and say all correct up at the top of the screen. When you get to that point, when it tells you that they're all correct, then advance to screen 6 and read the directions there. Let's see. So Rana, remember, we want to put things in linear versus non-linear. So anything that is linear on a graph, that means you'd be looking for a line. On a table, you want to be looking for a constant rate of change. If you guys get stuck at any point, please let me know. I'm happy to kind of help you talk through and look at any of these cards. Brennan looking good. Nicole looking good. Nasiba, you can go ahead and go on to screen number 6. Read the directions there on screen 6. Brennan looking very good. Oh, Brandon's looking much better. So one of the other things that you can do, if you're not quite sure where the problem is coming from, because remember, on the check page, if you have even one wrong card in a group, it counts the whole group as being wrong. So what you could do if you're not really sure where the problem is to take your group and pull it apart, but leave them close to each other on the screen, and then just add one card at a time and go back and forth and check. Because if you put two cards together and all of a sudden it's like, that's not right anymore, then you know that that card doesn't belong in that category. Who did I lose? Yasmin. Oh, there you are, Yasmin. It wasn't showing me yours on here. Fantastic work. It looks like you only need 2 more for your linear group. Kyla, looking good so far. All right, so let's see. Brianna, you've got 2 cards in your linear group that belong in the non-linear group, and you have 2 cards in the non-linear group that belong in the linear group. Yep, so you've got 2 cards that are in the wrong groups, Brianna. Looking good though. Let's see, Lauren, let me check in on yours. Remember, when we're talking about things that are linear, if you're looking at a graph, if it makes a straight line on the graph, it's linear. If it doesn't make a straight line on the graph, then it is not linear. Yasmin, nice work. So Yasmin, you can go ahead and go over to screen 6 now. Kyla, looking fantastic. Everything that you have matched together so far is correct. Let's see. Lauren. Lauren, of the cards that you still have in that non-linear group, there's one of them that shouldn't be there. 2 of the 3 cards are correct in your non-linear group. One of them should not be there. Brennan, let me check in on you. So Brennan, you have 2 tables in your linear group that don't belong there. Let me check in. Linear. So Rihanna, what's throwing things off right now is in your linear group, there's a table that doesn't belong. One of your tables that you have in, excuse me, that you have in the linear group does not belong. And that's what's throwing that group off. Lauren, your nonlinear group is correct so far. There are 3 more cards that belong in the nonlinear group. So one of the things that you can do so you don't have to tear everything apart is for the ones that you're a little iffy on, take 1 card from your linear group and add it to the nonlinear group and see if that says you've got some more correct. But so far, everything that you have in your nonlinear group is correct. Kyla, you are getting there, girl. Everything that you have in that linear group, Kyla, is correct. There are 3 cards that you have in the nonlinear group that actually belong in the linear group. Kyla, there are 3 cards that are in your nonlinear group that actually belong in your linear group. But everything that you have in the linear group so far is fantastic. Brennan, looking good. Brennan, everything that is in your linear group right now is correct. You still need 4 cards in order for that one to be complete. And one of the tables in your nonlinear group belongs in your linear group. Brianna, let me look at that. I want to say yes. So these aren't necessarily going to be equal piles. Rihanna, you've got 1 table that's in the linears that doesn't belong. And then you have 3 cards in the non-linear group that actually belong with the linears. Kyla, let me look. That was not the card. Let me see which one. Okay, Kyla, you have 2 tables that don't belong in your linear group now. There are 2 tables that don't belong in your linear group, and there are 3 things in your non-linear group that belong in the other one.
I have removed 3 things already from my non-linear.
Yes. So let me keep looking because sometimes there's a little bit of lag. Whose am I looking at? Brennan. Brennan, there are 2 tables in your nonlinear group that belong in the linear group. And there's 1 in the linear group that belongs in the nonlinear. So you want to be looking at your tables. That's the thing throwing yours off right now. All right. So Kyla, everything that's in your linear group is correct now. There are still 3 things and they're still over on your nonlinear pile. So of that group of 5 cards that you have for your nonlinears, there are 3 cards in that group that still belong over in the linears. Remember, we're looking for a constant rate of change. And there is 1 card in particular just throwing people off. So I kind of want to look at one of these cards to give you guys a hint. Brianna, let me pull yours up. Brianna, there is 1 table in each group that needs to be flipped. 1 table in each group that needs to be flipped. So let me pull this up. I want to look at some of the tables because that seems to be the thing that's throwing a lot of people off here. I'm going to show you an example for how I would approach a table. I'm going to get this guy out of the way. Just so I've got some room here. Okay. So when we talk about slope, can you guys tell me at all, slope means what over what? I'm looking for 2 words that start with R. Slope is what over what?
Rise over run.
Rise over run, yes. And so if I'm talking about rise, which axis does the rising?
Y.
Y. So when we talk about rise, that is the change in our Y's. That's what this little triangle right here means, is change in Y's over the change in our X's, because that's our run. So when I'm looking at a table of values, I can compare 2 ordered pairs, 2 points here. Let me pick a different color. And I will look at how much are the Y's changing by, how much are the X's changing by. So I want change in Y first. How much does the Y change by if it goes from 1 to 3? Or sorry, 1 to 4. If it goes from 1 to 4, my eyes went to the wrong spot. If your Y value starts off at 1 and ends at 4, how much did it change by? Yes, it changed by 3. Did it get bigger or smaller by 3?
Bigger.
Bigger. And then I'm going to look at the X's. It started at 1 and it ended at 2. Did it get bigger or smaller, and by how much? From 1 to 2, got bigger by 1, yes. So there is my rate of change between those two ordered pairs, those 2 points. Now I'm going to look at these two. So just this light blue rectangle, ignore the red for right now. And I'm going to look at the change in Y again and the change in X. So the Y went from 4 to 9, bigger or smaller, and by how much? If the Y goes from 4 to 9, bigger or smaller, and by how much? 5 bigger, yes. What about on the X side? How much did the X's change by? Did it get bigger or smaller, and by how much?
The Y stayed the same state as 1.
Yeah, the X changed by 1 again, from 2 to 3. So now I'm going to compare these rates of change. Here's the rate of change between my first 2 points. Here's the rate of change between my second 2 points. Did it stay the same? Is 3 over 1 the same as 5 over 1? No. Not the same. And so we would say that it is not constant. Not the same, so not constant. So I would put this card in the non-linear group. I can use that for all of my tables, and I can use that for the circles, because any of those circles I can take and change into tables. Because it tells you the X's and the Y's that match together to make an ordered pair. Anytime there's an arrow going from an X to a Y, they would make an ordered pair on my table. I want to show you guys what your homework is, because your homework is just finishing this up. As you finish up the card chart, after you get them all right, and you've located all the linear ones, screens 7, 8, 9, and 10, you're going to actually calculate the rate of change. That's one of the other reasons that I just went through this right here, is so that you guys would know how to calculate that rate of change. And after you type it in, so like on card M, I'm giving you guys a hint, these are 2 linear ones. If I said that the rate of change on card M was 75, and I click submit, it says that it's incorrect. You want to enter your answers on these until it gives you a green check mark, and then take a screenshot of it. You're going to need to upload screenshots for screens 7, 8, 9, and 10. That's the homework for tonight, is just to finish this out. If you get an incorrect answer, you just click in the box and try something different and submit again until you get those green check marks. If there's more than one question, you have to column at a time. Please let me know if you guys have any questions at all. You can reach me by Canvas messages tonight. I am more than happy to help you guys finish this out if you get stuck on anything. I hope you have a fantastic rest of your day. Kyla, running out of tries, you should still be okay, because even though you can't hit the try button, right here in this like short paragraph, it'll still tell you how many cards you have matched correctly. So even though you don't have any more tries, it'll still tell you here 9 out of 18 or 7 out of 18 or 11 out of 18 right there. But you should still be good.
Have a good day.
You as well. I'll see you guys tomorrow. Have a good day, Nasiba. Bye, guys.